Hi, everyone. I'm very glad to give me a chance to introduce my research. Thanks to NESCIM. My name is Chen and come from of China. I working in Kunming University of Science and Technology. Today, my research title is Model Construction and Performance Analysis for Asymmetric Compound Parabolic Concentrator with Circular Absorber. There were 5 parts of my report. First one is research background. Here, the volatility in the global energy market has intensified, and destabilization facts in the balance of energy supply and the demands have increased is significantly. The mass use force energy, which to the environmental pollution, we can look at this picture. And the electrical distraction and global warning, the temperature will be high and high day and day. And then there are lots of renewable energy. In the lots of the renewable energy, solar energy have the radiation research in the earth every year is equal 130 trillion tons of the standard coal. And the development of the solar energy does not pollute the environment. So it is one of the clearest energy. Then we can say solar energy is seen as the suitable alternative traditional energy source. Here, there are 4 points classification concentrators. First one is truth type. Truth type is a parabolic line. We can concentrate the solar rays to the focus line and get lots of solar energy. Another one is linear type and toilet type or dish type. But now, our research is non-imaging concentrators because these concentrators have no tracing device, so it can be work more sustainably. So we say is compound parabolic concentrator, such as CPC. All of the CPC, we got a newer asymmetric CPC, like this. This one and this one is different. Now, how to design a CPC that can efficiently work 6 hours a day? We can use the summer solid and winter simulate. If the 2 days the ACPC could work in 6 hours, that is to say, in the other days of the year, the ACPC could work in more solidly. Here, we can give the symbol angle is 6.7. Another one is 56.4. So we can give the equations as follow. This is the northern geometric shape. Another one is south shape. We can use equations. Third is the physical modeling manipulation. Physical model manufacturing is use the 3D point because 3D point is very useful formula. It is easy to manufacture the CPC model. Here we can give the 3-point manufacturing practice, such as the molding space is about 119 millimeters per second, and the printing temperature is 483 Kelvin degree. For laser and outdoor vacation experiment, in order to evaluate the concentrations of the ACPC, the air humidation continued to provide the ionizing environment for the experiment, and the dental effect was used to realize the validation of the ACPC concentrating process, which was conventional to vaguely, quickly, and effectively reflect the ACPC concentrating characteristics. We can find when the laser give out the light which around the ACPC surface, which is reflected to the absorber of the ACPC. And then, 4 typical incidence angles was selected during the experiment, and the laser emitter with incident at the each incident angle at 5 fixed aperture points. Now, what causes the error? In the left figure, there are 4 reasons. First one is the error of the laser experiment platform. Then the error of 3D additive manufacturing progress. And then the error of a fixed highlight reflect film. Last one is the instant monochromatic laser has a certain division angle. So we can find the max error is no more than 3.6 millimeters. And then the real sunlight outsource experiment is used for the ACPC. We can find in the outdoor experiment data, the indoor resonator estimates the position of the clearly observed form of the laser experiment value, and the real value is 4.6 and 3.5 respectively. That is to say, we designed the ACPC is respectively. Five, analysis of optical performance. From here, we can find when the incident solar rays is no more than its acceptable angle, all of the rays will be concentrated to the receiver. But when the incident angle is out than the acceptable, some of the incident rays will be received in the absorber. Some of them will out of the aperture. So we can find the optical efficiency of the figure. We can find the incident angle of the ACBC from 49 to 0.269. That is to say, the optical performance of ACBC is better than that of SCPC. When the incidence of the concentrating surface is 0.4, 0.87, 0.9, 0.93, and 0.96, we can find all of the ACBC optical efficiency is increased. The max one is 697.3 century. And the oleo remains collection around of the ACBC and SCBC will be researched also. We can find here that the radiation amount of ACBC in spring and summer is similarly lower than that of ACBC. We can find the left two. And while in the autumn and winter, the radiation amount is increased by 204 million joule per square meters and 645 million joule per square meters, which is increased 36.8% and 288.1% respectively. At last, we researched the ectomic of the ACBC. We can find all the geographic structure of ACBC is smaller than that of SCBC. So we can find the height of ACBC is only 124.1 millimeters, less than half of the height of SCBC. The radiation collection amount of ACBC per unit concentrating surface increased by 104.4%. Although the concentrator of the ACBC are saved by 37.7%. All of these we can find the ACBC have more excellent optical and radiation performance. So in the future, we can use the ACBC make the photosamurai conversion and research its system efficiency and make some applications such as dryer or cooling. That's all. Thank you.